Hello, in this class we are going to discuss about LTE, where A stands for Advanced. So today we are going to discuss about LTE Advanced, as it has some new features as compared to LTE system. So let's discuss that what are the goal of LTE Advanced. So we have some goal defined for this, and the goal for LTE Advanced are increased data throughput. That means we require more throughput values, so we have increased data throughput. So this becomes the very first goal in LTE Advanced, that data rate should be increased or we require more speed internet access. Then we have improved, or we require, or we are having a goal of improved flexibility of spectrum allocation. That there should be increased or improved flexibility of spectrum allocation. The very first goal, that we require more throughput. Then we have the second goal, that there should be increased flexibility of spectrum allocation. And then we require decrease latency. Latency is basically the time to travel and time for processing. So we require decreased latency, that means time should be very less to process. Then we require increased reliability. There should be increased reliability of data transmission. That means reliability, there should be reliability of data transmission, and we require this reliability of data transmission especially at cell edges. So that means we are required to improve the performance of data rate at the cell edges. So there should be increased reliability of data transmission and focused at the cell edges. So this, like increased data throughput, flexibility of spectrum allocation, we require decreased latency, we require increase in reliability of data transmission, and most especially at cell edges, and then we require increase in communication efficiency. So next one I will write here, that we require increase in communication efficiency. So these are the goal of the LTE Advanced which we require to achieve. Now as we have a LTE, now we require to move ahead from that, so we name it as LTE Advanced. So in LTE Advanced, what we require that there should be more data rate as compared to LTE, reliable data transmission, flexibility of spectrum allocation, we require latency to be very low. So these are the goal of LTE Advanced. When we achieve these goals, so we name it as, now we have LTE Advanced. Now, as I've discussed that our main aim that we require increase in throughput. So this increase in throughput, how do we achieve this increase in the total throughput values? So that means we require increase in TB size, where TB stands for transport block. So, as there should be increase in the total throughput, so we require that there should be increase in the transport block size. So, that means what we require to increase, so we require increase in modulation depth. That means we require to increase modulation. We require to increase this modulation depth. We require to increase modulation or use high modulation technique in the system. Increase in modulation depth, we require high modulation technique. So that means this is one, like we require to increase in the transport block size, that means you require to increase the modulation. Now, high throughput, like we require multiple carriers in the systems. So it is also dependent on, like we require multiple carriers in the system. Now this multiple carriers can be increased, like we have increase in, we require increase in bandwidth. So transport block size, we require multiple carriers in the system. That means to have multiple carriers in the system, what we require flexible spectrum allocation. So increased throughput is dependent on the TB size. With modulation, we require bandwidth with multiple carriers. So there should be flexible spectrum allocation. And we require increase in MIMO as multiple input and multiple output. With this, we require to decrease total transmit interval, that is latency. We require to decrease latency. So this is what, like, for increased throughput, these are the things that we require to make in our system, with the increase in the TB size with multiple carriers and MIMO. So for that, we require to improve modulation technique, we require to increase bandwidth, so we require flexible spectrum allocation. So that's how, like, with the help of this, we have increased or we have achieved the increase in the throughput values. So as we have increase in the throughput, like we have studied, now this LTE Advanced has a feature of carrier aggregation. So this is having a feature of CA, carrier aggregation. Now this concept of carrier aggregation is basically to have increase in bandwidth. So that means if we require to have increase in the bandwidth, so what we require to achieve, we require to have carrier aggregation. So with the help of carrier aggregation, we are aggregating 20 and extendable up to 20, like total of the 60, we can have 40 also. Now if we have maximum, like in LG we have 20 megahertz. Now we are aggregating together 20 plus 20, we can use 40, and then 20 plus 20 plus 20, so 60 megahertz. So this is concept, like this carrier aggregation concept is basically to increase the bandwidth of the system. And this carrier aggregation is a concept of LTE Advanced. Now coming what, as we require to increase the number of the layers for data transmission. So maximum number of layers for downlink. In LTE Advanced, the maximum number of layers for downlink are 8. So for downlink transmission, we have 8 number of layers. And what about the maximum number of layers for uplink? So for uplink, we have a total as 4. So 8 layers are simultaneously working for the downlink data transmission and 4 layers are working for uplink data transmission. So this is like we have increased the layers of the system. Now for implementation of the LTE Advanced, what we require. So I will make here in the center. Like this is my LTE Advanced. Now what are the things that we require to make it in? Like we require band and carrier combination. So first we require band and carrier combination. For implementation, we require to combine band and the carrier. Then we require different RRC component at radio resource control. Then we have MAC component, medium access control component. So band and the carrier combination to increase the RRC. Then we have we require CSI planning. And this CSI stands for channel state information. We require channel state information planning. We require to have more transmission mode in the system. So this is the transmission mode. We require to have like physical uplink control channel PUCCH and physical uplink channel. We require to have a check on it. Then we require to check both the formats of this system. Next one is downlink control indicator format that we require to have in a system. So that means these are the components of LTE Advanced implementation. So if we require to implement this as a LTE Advanced, so these are the various components of LTE Advanced, like aggregation of the carriers together as a carrier aggregation. We require RSC component. MAC component, we have CSI planning, in which we require to increase the transmission mode, the power up for the uplink, and DCI as downlink control information format. So these are the various components of LTE Advanced for its implementation. So as the very first feature that we have discussed for LTE Advanced, that it requires carrier aggregation to have an increase in the total bandwidth. Now as it required to increase in the uplink transmission, so that means it also required enhanced or the increased uplink transmission. So for that we have a technique for SCFDMA, and that technique is clustered single carrier frequency division multiple access. So we require another, that one is cluster. And this in cluster SDMA we have increased transmission of the uplink signal. Then we require to have increase in the MIMO. So we have enhanced multiple input and multiple output technology. So we name it as enhanced MIMO. Then we have LTE COMPT. Now this is coordinated multi-point transmission. Coordinated multi-point transmission. We will discuss this in our classes. Like what is coordinated multi-point transmission? It is basically transmission by coordination of the different E-node bits together. So like for LTE Advanced, we require increase in the uplink transmission. There should be increase in the MIMO, and also we require coordinated multi-point transmission in the system with one more left as a carrier aggregation also. So if we require to launch LTE Advanced in a system, so these are the things that we require to make active in our LTE systems. Now we have one more thing to be added here as in LTE Advanced. And that one is relay node. Let me see what is relay node and why it required. Now this relay node is basically required to improve data communication. So this node is required to improve data communication. Now data communication, especially like we have a condition here that we require to increase, no doubt we require to improve the communication of the data, but especially at cell boundary. Because we have always decrease in the data rate at the cell boundary, and we require to use these nodes at the cell boundary so that we can also increase coverage. So relay node are basically used to have enhanced or to improve the data communication or data throughput, but these are used with the cell boundary because cell boundary has the lesser performance, so that we can use at the cell boundary so that it can increase the coverage also and improve the performance of the system. Now as we have a E-node B, so we name it as like this is E-node B and D E-node B as donor E-node B. So I will name it as that this one is my donor E-node B. So as it is connected to the UEs, for example, this is my UE A, UE B. Now ideally at the cell boundary we have another as UE C. We have here as UE D. So we have UE connected. Now what in the relay mode what we require? We require to add on nodes. So this is the relay node as we are adding. So relay node. Now it is transmitting. So it is forwarding the signal. It is transmitting. A relay node is forwarding the signal. So that we can improve the data throughput at the cell boundary, as this is the boundary area. So performance for this UE is very poor. So we require to increase it. So this is my backhaul link for this backhaul. And for this one is my access link for this user equipment. Now, as we have one of the biggest problem in LT, that performance at the cell edge very poor, and this performance of the cell edge which is very poor, and this is more poor as compared to CDMA and WCDMA cell. So that means it is not as good as those cells. Now we require to increase with the help of relay nodes in the system, which is a feature of LTE Advanced. Now basically, like if this is my base station. Now this base station is sending a signal. So if this is a signal, so here in between I have a relay node. So this relay node will work as repeater and power amplifier. Repeater and power amplifier for the other user equipments in the system. Now, as we have attached here at the cell boundary, so it will improve the coverage or improve the signal strength for these user equipment. So this is basically some of the feature of LTE Advanced LTE COMP that we will cover in our next class. Thank you so much.